So this weekend you do have a written assignment. In your packet, it is page 16. So in your packet, you can go ahead and mark that entire page, which has 3 questions on it. You're going to be drawing lines on the graph, doing the calculations like we're learning in class. Will be due on Tuesday. On Tuesday, like always, we'll come around, check that page is done. Gentlemen, I'm giving instructions, so you should not be talking. You should be prepared when you get to class. Open it up, have it out. So we just go around, check, and then you check your answers, and then we take the quiz. And then you're going to go to the next section of Unit 3. There are only 2 sections of Unit 3 left after this, Section D and E, which means we're going to be starting to get ready for our test on Unit 3 as well, which I'll talk to you about once we finish today's page 14 and 15. That's all I have to do with you. We're almost done with 14, and 15 is pretty quick as well. Then what we'll do is we're going to start Lab 7. You're going to get 2 full class periods to work on Lab 7. So this period 6 today, and then a period 6 on Wednesday next week. You don't have classes on Monday, so you'll be finishing it. If you don't finish it today, you'll have that class period. If you finish it today and turn it in, that's fine. Then you'll have a class period free to work on the review assignment for Unit 3, which will be due on Monday the following week. I am prepared to hand back your Unit 2 exam before you leave today. And as you can see up here, the corrections for that are going to be due back on Monday the 27th. I'm actually giving you an extra couple of days. Normally, I hand it back Friday. It's due Friday. I'm giving you a few extra days. As last time, if you do the corrections, you want to make sure that you have the correction sheet signed in order for me to give you credit. Now, let me explain why I'm giving you the couple extra days. Next week, hopefully, I am not here. If I am here, that's not good. And I'm going to tell you why. The surgery I had, if you haven't figured out, I have breast cancer. And I say have. I can't say had. I thought I was going to be able to say had, but they didn't get it all out. And actually, the pathology showed that I have not just 1 type of breast cancer, I have 2. And the second one was a big surprise. And it was like, crap, we didn't know it was there. It's not showing up on any imaging. So I have to have a lot of additional testing done before. So I'm having what they call a PET scan on Monday morning, which is the most sophisticated cancer detection test that exists. And hopefully that shows nothing. If it shows something, it means I need a much bigger, more complicated surgery. And then I'm going to be out for a long time recovering from that. I'll be in the hospital probably for a week after the surgery. And then I'm not hoping that's not what it is. So I'm saying I'm hoping I'm not here Tuesday, because if I'm not here Tuesday, then they didn't find anything significant on the PET. They're just going to go in, take a little bit more out, and hopefully I'm good. If not, and I'm here Tuesday, that's not a good thing. So you are actually, I hope you're hoping that I am going to not be here Tuesday, right? Because if I am, then Mr. Walters will actually be teaching you, not showing videos of me for 1, 2, 3 months. Okay, that's the kind of time I would have to take off after that next surgery, if that's what I have to have. So hopefully I just get the little one on Tuesday. I'm in and out of the hospital in 2 hours. And I'm just at home because I'm on some pain meds and I can't drive. And then I'll be back. All right. So you will be finishing this. And next week, you're just going to be doing what you did when I was out the last time. Okay. Any questions on that? Life sucks. As you get older, it gets worse. So I hit the big 5-0 last year. So I'm like, oh, great. Nosedive. But I've got a good attitude about it. It's not going to be a big deal. And hopefully everything is just fine. So anyway, let's get into finishing Unit 3C. Okay. So let's look at Unit 3C here. Yeah. And we are on page 14. So could you please turn to page 14? Yeah, so the test corrections, as I said, they're due Monday the 27th because that's when I'll be back. If I have surgery Tuesday, I'll be back that way. I'm not coming in that Friday afternoon to come pick up your test corrections and grade them over the weekend. I'll get them when I'm back in school the following Monday, the 27th. All right, so yesterday, if you recall, we learned about drawing two different kinds of lines for these position time graphs for accelerated motion, right? They're parabolas. Parabolas here show us that we're accelerating. And yesterday, we started off by determining how this object was moving just based on the shape of the graph, which is what you learned while I was out. And now we're talking about how to do the calculations with this. Average velocity, we used the secant line that we drew. We labeled it. We used 2 time points on that graph to calculate the slope, and we used our guess method. We left the class by saying now we want to calculate the velocity at 0.75 seconds. So what we need to do now is go to this graph and figure out where is 0.75 seconds on the graph and label it. So let's go ahead and do that. So 0.75, if I look at the scale that's used here, every other line is 1/10 of a second. So 0.5, 5, 5, 6, 6, 5, 7, 7, 5 would be right here. I'm going to label that, as you should be doing too. And then what I'm going to do is go up to the curve. I'm going to mark where that is. That's 0.75 seconds. Bryce, you should be following along in the packet with me right now. 0.75 seconds right here. Okay, let's go back to how do we find a velocity at one time, which is called the instantaneous velocity. We have to draw a line on this graph there. Do you remember what that kind of line is called? Tangent line. That's right. We're going to use a tangent line for this. And yesterday you saw in the presentation kind of like zooming in on the parabola at that point. What I can do that you can't do, and I'm going to do this for you, is I'm actually going to zoom in at this point with the camera, the document camera. So let me go ahead and do that. Refocus it. There it is. And if I look right in this area, can you see it looks like a line segment right there? So what I'm going to do is I'm going to mark 2 points, one on either side of that dot. I got it, Suchan. So I've got my 2 points marked on either side. So what you'll need to do as you do these questions moving forward is imagine what we just did. Zoom in, find those points on either side and mark them. And now when I zoom back out to the regular view, you can see I have those 2 little marks on either side of the dot. Now with your ruler, what you're going to do is connect those points together. Connect all 3 together. And then go ahead and draw in a line as far as you can. Expand it forward and back. And that line, which I'm going to label over here, is the tangent line. So your tangent line should look similar to what I just did. Is it going to be exactly the same? Probably not. The only way you're going to get the exact same tangent line as me is if you photocopy this. So Colin, end the pass and then let's get back to this. All right, so now what we're going to do is we are going to mark, we're going to just find the slope of that line that we just drew, that tangent. Find 2 points on that line that you're going to use in your slope calculation. Now, let me give you a hint. We always want to try to use points that are as far apart as possible on the line. That always gives you the best, most precise answer you can get. But the next hint is you want to try to find points on the line where a horizontal grid line is intersecting a vertical one. And the reason I suggest you do that is because then it's easy to read down to get the x coordinate of that point and read over to get the y coordinate. Do you understand what I mean? All right, so let's go ahead. On your line, I want you to find 2 points where grid lines intersect. And hopefully you have 2. I don't have 2. So I'm going to have to interpolate. Actually, that's not bad. I'm going to use that point right there. That's going to be 0.2. Oh, that's the only, do I see any other ones down here where grid lines intersect? No. So I'm going to use that as my 0.1. You have to pick 2 points on your line. Yeah. You don't have any?
I have one.
Okay, so then another one, try to get as close as you can to like halfway. Okay, you can't approximate. If that's, yeah, see, that's about halfway, but you do the best you can. Okay. Now what you have to do is continue with your guess method for solving this. So I'll show you how to do that. And of course, my coordinates may be different than yours, and that's okay. It means we may not get the exact same answer, and that's okay. What I'm checking when I grade this, the tangent line you drew, is it appropriately drawn? So do you understand how to draw a tangent line? And then where are your 2 points? And then I'm checking that those points, when you put them here, that you got the coordinates correct and did the math right from there. So my first point, you have to list the X and Y coordinates like we did yesterday. So my X coordinate would be 0.95 seconds. And my Y coordinate here, when I read over, is 55.00 centimeters. Notice you have to keep the precision from the axis labels. So did I just say that was 55.00 centimeters? And then I'm going to do my second point. There's my second point. Come down, that is 1.10 seconds. And the Y coordinate here looks like 70.00 centimeters. Now, the way we write the unknown for velocity is just like we did in the last unit. It's just V with the arrow. If you put the bar over it, do you remember what the bar means over the V? Average. It means average. This is not asking you for the average. That was here. So this is just V with the arrow over the top. We write the same equation. V with the arrow is y2 minus y1 over x2 minus x1. We then do our substitution with units. So that means I'm going to do 70.00 centimeters minus 55.00 centimeters over 1.10 seconds minus 0.95 seconds. Just like we did in the last question, do your intermediate subtraction step first so you can keep precision. So that's going to give me positive 15.00 cm over 0.15 s. My numerator has 4 sig figs. My denominator has 2. So I'm going to round to 2 significant figures, and I need to include the direction, which is positive in this case. I then divide that out on my calculator. And that gives me an answer positive. Oh, I need 2 sig figs. I'm going to have to go to scientific notation. Positive 1.0 times 10 to the 2 centimeter per second. I have to use scientific notation because my answer was 100. I can't write 100 with 2 sig figs unless I use scientific notation. You probably didn't get 100. And that's okay. You get what your calculation gives you if you did all the math right. But you do need all of these steps like you just saw me do here. So I'll give you a minute to finish off yours. Make sure you're not leaving off any units anywhere. I will tell you when I did this with my last class, their packet. I'll show you what I got with my last class. I had a slightly different drawn tangent line. With my last class, I had points at 0.40 seconds and 1.35 seconds. I was able to get an answer of positive 95 centimeters per second. So there was my tangent line. It was a little different, not much, but it's close to 100. 95 and 100 are pretty close to each other. It's not like I'm getting 250 or 5. They both round to 100. Okay. Any questions on page 14? Can I go on to page 15 with you then? And then we'll start working on the lab. Okay. Page 15 is giving you a different position versus time graph. So before we start answering the questions on this page, like yesterday, I want you to add something here. I want to give you a minute for you to write the description of motion for this graph. Go ahead and do that off to the side, please. I want to make sure you all understand how to do that before we then do the calculation piece. We discussed how to figure all that out yesterday. That was a review from Unit 3B. Everybody have their description written? All right, let's check your description. You should have said that this object was moving to the right and it was speeding up. Moving to the right because the graph was going up, speeding up because it's getting steeper. Since it's moving to the right, that means the velocity is positive. Since it's speeding up, the acceleration has the same sign as the velocity, so it's also positive. Okay, did everybody get that description? All right. Yes. If you're asked for it. Okay, so let's go to part A. Now I want you to calculate the average velocity from 0 to 1.5 seconds. Bryce, I don't know what you're doing there, but whatever you're doing, it's not on the page. So what kind of line do we have to construct? Who can tell me the type of line we need to construct for this? Dan? A secant line, that's right. We need a secant line. Since there are 2 time points involved, you're going to find those 2 time points on the graph, circle them. That's where we need to go to make our secant line, connect them with your ruler. Remember, you extend your line nice and big and far. And I'm going to label that. That is my secant line that I'm going to use for part A of this question. Okay, now we're going to identify 2 points to use that are where grid lines intersect. I'm going to use the origin. That's a nice, easy point to use. And I'm going to use the one right at 1.5 seconds because that's on both a vertical grid line and a horizontal one. So that's going to be my point 2. All right, now you got to give me the givens. Jacob, can you tell me what my givens would be for point 1, please? Correct. And thank you for including the precision on that to 0.0. We keep the precision that comes from the labels on the axes. So since my times are all going to the 10th place, I need to keep mine to the 10th place. All right, how about point 2? Mia, can you help me with that, please? Very good. Thank you. Brody, can you tell me what my unknown would be written as? Excellent. V bar with the arrow. Marnay, can you tell me what equation I should be writing to do this? Yes, but we need the bar. And that displacement is found how? With these givens, what do I need to do? The slope. So that means I'm going to do y2 minus y1 over x2 minus x1. It just so happens that in this case, this y2 minus y1 is the displacement. And this x2 minus x1 is the time. So what you said was not incorrect, but it doesn't work with the givens that I have. Okay, let's now do our substitution with units. So V bar with the arrow would be 8 meters minus 0 meters all over 1.5 seconds minus 0.0 seconds. Do your intermediate subtraction. So the numerator would give you positive 8 meters with the correct precision and 1.5 seconds in the denominator with the correct precision. You're now going to divide that out, getting an answer with proper units, sig figs, and direction. Shane, do you have it? What is the direction? Or positive. Make sure you keep that there, otherwise you didn't give me a velocity. So positive 5 meters per second, or you could say 5 meters per second to the right. Remember, in this unit, we are assuming that the positive direction is right, unless we're told otherwise. Any questions on part A? Okay, let's do part B. Now I want you to find the velocity, the instantaneous velocity at 1.0 second. So you're going to find 1.0 second on the graph and mark it, which I'm doing right there. There's my 1.0 second. What kind of line, Nikki, do I need in order to find this kind of velocity? That's right. This one needs the tangent line. Now, I'm going to just freeze my screen. You guys can go ahead and draw in your tangent, what you feel is your tangent, and then you can compare it to mine. Okay, do you all have a tangent line drawn? You want to check it against what I got? See how it looks? Now, I did mine in red so you can see it differently. It stands out to you. So here's my tangent line drawn at 1 second. I made my little marks on either side of that dot on the curve. And then I connected them with my ruler and I made that nice big long red tangent line. So that, does yours look similar to that? Good. I will tell you the most common mistake that I see is that students want to connect 0 to that time point. That's not how we draw tangent lines. We got to try to approximate. Imagine zooming in right there and then just making that little line segment that we see even bigger. Now you want to find 2 points on that line. I'm going to use this one right here. I think that's a good point to use where the x-axis and the vertical grid line at 0.5 seconds meet. So that's going to be my first coordinate. And I got to find another one. I'm going to use the one right at 1 second. That's going to be my second one. Because that was right where 2 grid lines met. Anyway. Okay, so now we have to do our givens for those 2 points. Logan, can you give me the givens, please, for point 1? I'm sorry? No. Point 1. 0.5 what? Comma 0 what? Okay, you got to put units on everything. Joshua, can you give me my coordinates for point 2? Okay, this one. That one was for my secant. There you go. So 1.0 seconds, comma 4 meters. Eric, how do I write my unknown for this? That's right. Just V with the arrow. We don't put the bar because the bar translates to what word? Average. It's not average. Okay. Jackson, can you tell me what equation I should write for this? Correct. Let's now go ahead and do our substitution with units. So V with the arrow would be 4 meters minus 0 meters all over 1.0 seconds minus 0.5 seconds. You're going to do your intermediate subtraction. So the numerator gives me positive 4 meters. The denominator, remember when we subtract, we keep precision. So I would get 0.5 seconds. From this, I see the numerator has 1 sig fig. The denominator has only 1 sig fig, which means my answer is going to need how many sig figs? Just 1. So let's solve that for the velocity. Si-Chen, can you tell me what you got? That's correct. Another way we could have said that would be saying 8 meters per second to the right. Okay? Any questions? All right, so what's your homework? And notice that on page 16, there's just 3 of them. 3 of them that you have to do. So you should be drawing 3 lines on this graph when you do it. At the end of today's class, you'll have time to work on that. But for now, I'd like you to put this away and take out your Chromebook. Put your packet away, put your ruler away. All you need now is your Chromebook. Just your Chromebook, please. You won't need rulers. You won't need pencils. You won't need calculators. What do you need? Just a Chromebook. Just a Chromebook. If you happen to finish the lab, that is the next on our agenda, then you can start working on the homework. That's due Tuesday. And I say Tuesday because Monday is our superintendent's conference day, so you don't have classes on Monday. And yes, we do have a double today, so there's a good chance you'll probably get lab 7 done today. It's not really that long a lab. I had a lot of students in my other class that has a double opposite you that finished it yesterday in 25 minutes. So you've got the whole time. But you should be focusing on this activity. Just like when I was home recovering, I'm going to be able to watch everything you're doing on your Chromebook. And if I see you off task, I'm giving you a 0 for the day. You need to keep your attention focused on getting this done. Now, what I'd like to do is show you how to get this lab completed. I'm not going to do any of it with you, but I am going to give you some things that you want to pay attention to so that way you can get this lab done correctly. So lab 7 accelerated motion. You're going to open up the Google Sheet. And this is what you see. That I did give a video from a couple of years ago when I gave instructions to students. So if you are having to finish this up on your own without me here, you can go back to that video to get those instructions if you need it. But you are also going to need this PhET simulation. So go ahead and open up the simulation. You should be familiar with this simulation from the Moving Man Lab, lab number 5 that you turned in and completed. Most of you. Some of you still have to turn it in. It is now way late. It was due more than a week ago. When you open this up, you will see that you have 3 sliders in the simulation. If you don't see all 3, then what you have to do is go up here to your Chrome tab, the top 3 dots, click those 3 dots and reduce the zoom level. And then refresh the simulation so that way you can see all 3. Because in this lab, we are not looking at that man moving at a constant speed in any direction. He's either going to be speeding up or slowing down as he goes to the right or the left. That means he's accelerating. So you will not only be inputting initial position values, initial velocity values, but you're also going to be inputting a third value for the acceleration as we do this. Now follow along with me in the Google Sheet. You'll see that there are 4 tabs at the bottom. I'm not even going to worry about this first tab for the setup. That's the same questions I asked you in the last lab. Do you know how to play the motion, record it, play it back, all that stuff? Please go to Part 1 Data Collection. In Part 1 Data Collection, this is set up differently than the last lab. So please look up at the screen. You'll see that when I look at this tab in the Google Sheet, that I am giving you 4 data tables to complete. Motion 1, Motion 2, Motion 3, and Motion 4. You're doing all the data collection on one Google Sheet in the shaded cells instead of going to 4 different tabs. It's all in one place. Make sure you follow the directions for each of these tabs or for each part, each different motion. Make sure you start off every time by resetting to 0, starting off with a position of 0, which means that my first position at time 0 should be what value? 0. You just type 0, and it will automatically change it to the correct number of decimal places. Then start off with a velocity of 0. So guess what my velocity at time 0 should be? 0. This third parameter for the acceleration right here, you're going to have to input. And that means we're going to see changes in the position and velocity as time goes on. None of these values for the position here or the velocity here are going to be the same. Remember the last lab, the velocity numbers didn't change? They are going to change now. Every single half-second time increment, you're going to see a change in all of it. You're going to input them. Then you're going to go to motion 2, do the same thing, but follow using the parameters given to you. Just follow it and fill it in, okay? Don't do that yet because I'm going to give you all my directions up front and then I'm going to say, good, go, get it done. So follow along with me, please. Go to Part 2. I need you to pay attention to what's written at the top of Part 2. You see what it says? Big blue letters. What does it say? Don't edit it. Do not touch the data tables on this tab of the Google Sheet. Don't. If you need to make a change to something, you have to go back to Part 1. The reason is behind this data table here in Part 2 and this data table here in Part 2, there are formulas behind every cell that's there. You see how this number, if I click on it up here in the formula bar, it gives me a formula. I've done some programming on the Google Sheet to take all the numbers you already typed in and pull them in. So this will automatically be populated for you after you complete Part 1 of the lab. One thing I do want to mention, some of you with Lab 5 when you typed your numbers into these data tables, you followed every number with a unit. Do not do that. You just type in the values. Where are the units? They're in the column headings only. If you put a unit after a number in these sheets, your graphs turn out like crap. And you're going to be like, why isn't this working the way I want it to? Because you didn't type in data, numbers, numerical data for it to graph. That's just the way that the program works. Only numbers get typed in, okay? So, oops, wrong thing here. So here we're going to type all our data in. Come on. Then we're going to go to part 2, and we're going to see that these data tables will be filled in. They're not yet. Don't even worry about that yet. I need to explain the graphs. So please look at part 2, question 1. Notice I am giving you very specific instructions on how to complete your graph. Bryce, I need you focusing on this and not working ahead, because you're going to be the first person to ask me a question or give me grief as to why you're not getting things done and why it's not working right. Notice that the directions say, below this, you're going to make a position time graph. It's not going to give you the kind of graph you want. It's not going to give you a scatter graph. It's going to give you a bar chart. Notice I'm telling you what type of graph you have to create. I'm telling you the type is scatter, okay? You know how to change the type. We've done that before. So please do that here. Then make sure you have all of these things on your graph before you're done. You need to have all 4 on the same graph. You need to make sure you put an appropriate title. You need to make sure that your X and Y axes are labeled with the variable names in the units, that there's appropriate scaling, meaning that the X axis starts at 0, that you put a trend line for each of them, the equation for each of them, and there is a legend so I know which color line or curve goes with which motion. Now for this graph, I have to tell you that we're going to change this up a little bit. When you make your position time graph here, the trend line you're going to pick is not the type that we expect. We have learned, I've told you previously, that whenever you get a curve, what type of trend line should you pick? Okay, not in this lab. The reason is because you're going to have data that's down in the 4th quadrant. It only does power series in the 1st quadrant. So for this one, you're going to want to pick the polynomial trend line. You pick the polynomial trend line, okay? Then you're going to do the same thing for the velocity graph. Make sure it's a scatter graph. All 4 on the same graph grid. It has a title. The X and Y axes are labeled with their variable name and unit. Starts at 0 on the horizontal axis. Trend lines, equations, and the legend, and you're going to put it right there. That is all of part 2. Then I'm going to ask you to go to the conclusions tab. And on the conclusions tab, you're going to see all these fill in the blank questions that you're going to answer. Where are you going to get most of the answers to this? In your notes, if you don't already know it. If you know it, great. Go ahead and put it in, but hopefully it's right. You may want to check your notes to make sure you know. The only one you will not know the answer to yet is number 3 for the velocity graph. Nope, that's not it. Number 2. Number 2 for the velocity graph you don't know yet. But I bet you can probably figure it out because you know how to calculate slopes. So if you think about what's on a velocity graph and what the units are when you find the slope of that, that will probably tell you what that's going to be. Why don't we take our break, and when you come back, I'm going to be pairing you up to collect your data. So you're not working with the person sitting next to you. Go ahead, take your break. When you come back, we'll talk about how we're going to collect this data. I did not. I'm sorry.
used it yesterday, but I can't find it.
It's not anywhere in your backpack.
No, I took everything out.
You did. I'm sorry. You're welcome. You should be able to plug in right behind you. See on that, Logan. Look at the I probably will. I've had kids reach from there before. If not, I'll have you move. You got it, right? Yeah. How are you, sweetie?
How are you? I heard you're back.
Well, I'm back for now. You talk to Grace and she'll tell you. I have to be out. I think. Hopefully I'm out next week. Otherwise, I'll be out for next week. If I'm another 10 minutes. Yeah, I'll get through it. Oh yeah. Yeah. It's just not fun getting there. That's it. I'm like, I don't like going out. I don't like being cut open. I'm still in a good amount of soreness. But Grace has been great. Every night she fills up my ice bag and I sleep with ice on me every night. And yeah. She's really nervous stuff. So how are you doing?
I'm doing good.
Yeah.
I miss physics. Can't believe I'd ever say that, but AP Bio was worse. So much worse.
So like, did the doctor like I know there's like a bunch of like different causes of cancer.
Right. Yeah.
Was yours like more like genetic or like,
No. No one in my family has breast cancer. I'm the first one.
what do you think could have like caused it to happen?
Don't know. Really don't know. My doctors can't give me an answer to that.
Hopefully there isn't like a repeat because like
Yeah, I
for
know. That comes back bad. Yeah, that's why I want to make sure we get it. I gotta do everything they tell me to do. Thank you. All right, ladies and gentlemen, let's take our seats and let's talk about how we're gonna finish this up, okay? Because I don't think you know how to collect data with the simulation. So you don't need to spend 40 minutes collecting data. Nor do I think you individually have to collect all 4 motions. I think that's a waste of time. I think if you partner up, one person does 2 of them, the other person does the other 2, and then you share, that's a better use of time. Does that make sense? And then you can go on, help each other make the graphs, help each other answer the questions. And when it's done, you turn it in. If you don't get it done today, not a big deal because you are going to have one more class period next Wednesday to get it done. And if it's already done, you're going to have that class period to work on the Unit 3 review assignment. Make sense? Any questions for me? Okay, so I'm going to pair you up so that way you can get this done expeditiously and not feel like, oh my God, I have to repeat collecting this over and over and over and be completely bored with it. So can I just have the 2 of you work together right next to each other? So Jackson, can you scoot down that way you can work with Shane? Help him get that done. While the 2 of you work together, the 2 of you together, the 2 of you together, 2 of you, 2 of you, 2 of you, 2 of you, 2 of you. All right. Remember, so you're gonna get that unless you want to switch. Did you want to switch? Okay. What I will do, you so talk to each other, figure out who's doing motion 1 and 2, who's doing motion 3 and 4, and share the data once you got it. And then you can work on your graphs together, maybe check each other's work and so forth. Meanwhile, I'm going to pull up what I looked at home while I watch your Chromebooks on my screen to make sure you are on task. Make sure you are focused. Because I won't be so nice today if you are not on task. If you're not on task, you're not going to work on the lab anymore here. You'll have to do it all for homework. The nice thing about me being here is while you're working on it, if you have a question, you can, of course, stop and ask me too.